Hello there, my name is Karan, and this is my paper side video for my Pascal's method task assignment for grade 12 data management. So there are three methods to solve problems relating to Pascal's method. The first method is drawing out your methods and your roots. Second one is using Pascal's method itself, which we learned in class recently, and also using combinations, which we also learned in class recently. So moving on, I'm going to be talking about drawing out our roots and methods. So pretty much just drawing out your roots and methods is just a basic diagram illustrating to yourself the total amount of possible routes you can take to get from a certain point to another point. So for example, in this 2x4 square, to get from point A to point B, there is 6 routes in total. So there's route 1, route 2, route 3, route 4, route 5, and route 6. These are the 6 possible routes you can take to get from point A to point B in this square. However, drawing out routes is most effective only when you have a small square like the one I provided in my example. If you have a larger square, for example, a square that is perhaps 6 by 7, it'd be more difficult to do this method as it will take time to do. And in that case, it'd be more effective to do something such as a method we'll be talking later on in the video, like using Pascal's method or using combinations. So moving on, I have a question to ask. So how many ways can you get from point A to point B only going east and south, so only going left and right? So to get to point A to point B, there's 6 possible routes. The first route is you go to the east 2 units, south 2 units. Second possible route is you go to the east 1 unit, south 1 unit, east 1 unit, south 1 unit. The third route is you go to the east once, south twice, the east once. The fourth route is you go to the south 2 units, the east 2 units. The fifth route is you go to the south 1 unit, the east 2 units, south 1 unit again, and the last route is you go to the south 1 unit, east 1 unit, south 1 unit, and east 1 unit. So in conclusion, there are 6 different ways to go from point A to point B following the restrictions, which is only going east and south, so right and only going downwards. Moving on, I want to be discussing Pascal's method. So Pascal's method, as we learned in class last week, is the 2 terms above the term are equal to it. So for example, 2 is equal to 1 and 1, 3 is equal to 2 and 1, 4 is equal to 3 and 1, and the first row is always row 0, then row 1, row 2, row 3, row 4, row 5, etc. And Pascal's method could also be used in real life to help us with things. And this method can sometimes be better than the previous method I discussed, because for example, if you're trying to find the total amount of roots for a square that perhaps is 6 by 7, you could use Pascal's method opposed to using the drawing out roots method, which will take more longer and be difficult to do. So I have a question regarding Pascal's method. So John wants to select 4 different chocolate bars from Sobeys, but he can only take 1 bar from each of the rows. What is the highest amount of possibilities John can have? So these are just representing chocolate bars so I can be more creative to the reader and the person doing the actual math question. So as I was talking about Pascal's method in the previous slide, it's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So in order to find the total amount of possibilities, so John's selecting 4 different chocolate bars, you go to the last row and you add up the numbers. So it'll be 1, 3, 3, 1. 1 plus 3 plus 3 plus 1 equals 8. So there's a total of 8 possibilities that John can choose from Sobeys. Now I'll be talking about combinations. So the formula for combination is NCR, and N and R are just the subscripts, and this formula is written as N to the exclamation point over N minus R exclamation point. So here's a Pascal's triangle again, and then these are the rows I was talking about, but I didn't discuss in the previous slide, but now I will, that the numbers in the bottom are the entry numbers. So like for example, 4 and 0, this represents that this is in the 4th row and it's 0. 0 is the entry number. So here's a question I have relating to combinations. So the checker piece must reach the center of the board. The checker can only move diagonally and forward towards the center of the board. What is the total amount of possible combinations? So here I'd use the formula I discussed, NCR. There's checker piece, so it'd go 1, 2, 3, 1, 2, 3. So you would do 3C2. So 3C2 is equal just to 3. So the total amount of possibilities for this question is 3. So I hope you learned a lot from my video and how I discussed the 3 different methods relating to Pascal's method that you could use to solve questions. And thanks for watching. Have a good day. Goodbye.